Hello guys, welcome guys to lesson 2 of the dissertation, and this will be in lesson 2. So if you're just joining us, if in case you missed the lesson 1, you can check in the description below, or in the I will drop the link in the comment section or to the description attached to this video, so you can check it too. Okay, now let's look at the differentiation itself. Okay, in the previous class we discussed about limitation of differentiation, but here we are going to be discussing about differentiation itself. We dive into the calculus. Now, before I will under this video, you're going to learning the general expression, how to express differentiation question and how to solve differentiation question. I'm going to explain everything in a step by step. Okay, so if you don't understand any part, you can let me know in the comment section. If you don't understand any part of this lesson. Now, let's go without wasting much of time. I remain your guy, Maki Waedeji, Andrew, the founder of Makosh. So let's dive into differentiation. Now, the first thing you should take note whenever you're given this question, how do you identify them and how do you solve them? In a differentiation, it has its rules to follow, and it has a general expression to follow in differentiation. Let's look at the general expression and how to differentiate the general expression with using a question under differentiation and how do you attempt to solve it. Now, let's further discussing the general expression of this word differentiation. Now, if a question is given, in differentiation, it will be equal to, it will usually give an expression, the first rules and the general expression in this differentiation, it will be equal to, we have y is equal to, we have s with power of n. Okay, this, let me say this one is the first case. Okay, and also explain the second case for you. So if I give an expression like this, y is equal to s with power of n. Okay, so I will taught to find what to differentiate this y with respect to s. So, and the question said that it will be the y, okay, the s. We'll differentiate this y with respect to s. Now, if we want to differentiate this expression with respect to s, it will be equal to the if you look at this pattern, we have two part there. We have the base, and this is the index. The index is n, while the base is s. Now, this n we multiply by this base here, it comes and multiply by this base here, that will be what? That will be ns, and then you subtract 1 from this index, that will be what? N minus 1, then we have differentiated this expression. Now, the solution to this expression is equal to what? This. So when you give an equation like this, the y, when you give an equation like this, y equal to s with power of n. So in this expression, if a given equation in differentiation is usually to be like this expression, this is the general form of differentiation, and we differentiate this y with respect to s. It means that the index here, we have the base and we have the index. So the index here will multiply by this base, that is I have n multiplied by this base here, which is s, and then we subtract 1 from the index, that be what? N minus 1. That is this case. What if in the second case? The second case, this one is not that mentioned like convincing. If they are give them a question like this, they are used to convincing in the second case. Now, let's say that we are given this y to be equal to s. This one does not have any index. Okay, this one does not have any index. Now, if you are differentiating this this s, so if you're differentiating this the y ds, if I give it a expression like this to respect to s, so the solution to this one to be the y, okay, the s, I want to differentiate it with respect to s. Now, if you look at this question, if you look at this expression very well, this one does not have index. This one has index as any given number. But if you take a look of this one, of this question, this expression here, this s does not start alone. It has index where the index is not visible. So if you just have a number that I have 2, this 2 is base power of something, which is 1. Which is not visible. So 2 is power 1 is still the same thing as 1. So the same thing applicable to this base. It means that this s is raised power of 1, which does not what? Visible. So the 1 multiplied by this s, that will be 1 multiplied by, okay, 1 multiplied by. Now, if you look at this part, if you look at this place now, here we have 1 minus, you have 1 here, not subtract 1 for the index. This I said that the 1, we have 1 here which does not visible. I get down because this one multiplied by this. If you have a number that just stay like this, like 2 here, this 2 is principal of certain number, which is 1, it does not work visible because 2 is by 1 is still 2. The same thing here, s principal of 1 is still what? S. So this one here multiplied by the base which is what? Okay, let me say multiply by s. Okay, let's multiply by s. Now you know subtract 1 from the index. So that means that 1 minus 1. I get now 1 minus 1 that give us 0. So that means that we have what? 1 multiplied by, that is 1 multiplied by 1 minus 1, that is 0. So we have s raised power of 0. And if it's 2 member indices, if we have any number, then raised power of 0 is equal to what? 1. Okay, any number base power of 0 is equal to 1. So therefore this one becomes that is 1 multiplied by, okay, 1 multiplied by 1. So because s is power of 0 is 1, so 1 times 1, that's equal to what? 1. So therefore with this expression, if we differentiate what? Y is equal to s, and we differentiate with respect to s, means that our dy, okay, the s now is equal to 1. So if we differentiating any given expression that look like this, here is not 1 there, that look like this, the answer is equal to 1. That is how you solve any differentiation question. These are the rules you should follow if you're solving any differentiation question. I get now. These are the rules to follow if you're solving any differentiation question. Let me just give you one simple example. Okay, let me just give you one simple example before we dive to the main example. Let me just give you one simple example. Now let's say that we have we're given the question. Let's say that we're given a question that's differentiate that this expression of y. Okay, let me say example. Okay, we have example. So let me say this example 1. Okay, let's put it as example 1. So if I give us example here, the says you differentiate y equal to, as s is power of 3. If we say that to differentiate y is equal to s raised power of 3, now the solution to this given expression is quite very simple. Now how do you attempt to solve it if we're given this expression? Let's look at the way we can solve it together. Now to differentiate this y respect to s, it will be equal to, that to be the y, okay, ds with what I explained here. This one is just in form like this. That means that the index here, we have the base here, we have the index here. So these are the index multiplied by this word base, that will be equal to, that is 3 multiplied by what? S. That gives us as 3s. Now you know subtract 1 from this word index, that is what? 3 minus 1. I get now. Now therefore this one now becomes what? 3 minus 1, that is equal to what? 2. So the answer to the solution to this question is equal to s 3s raised power of 2. So when we are differentiating y is equal to s raised power of 3, the answer is equal to what? The ds of it is equal to 3s raised power of 2. I get down. You can see how simple is this question. You can see how simple is this question. So when you just know when you just know the general expression of the differentiation, this first case here, if you just know the general expression of differentiation, you can make it easy to solve. You have y to be, if you give an example that y is equal to s raised power of n, this means the base here, the index here multiplied by the base, and you subtract 1 from the index. That is solution to it. So do you get it now? That is the step-by-step to solve any differentiation question. Okay, let me give you one more example from the material I'm using. Okay, let me give you one more example from the material I'm using. Okay, let me give you one more example because of the length of this video. Let me share with you one more example. So if I've did one example, let me give another example. So let's say that we have the example 2 before we move to let's say that we have the example 2. Okay, so in the example 2 is almost the same thing. What if we are given a question? Okay, let's say we are given a question that have this expression. We have y to be equal to, we have s raised power of 2, okay, plus s. So we're trying to differentiate this one with respect to s. Okay, we're told to differentiate this question with respect to s. Now, how do you attempt to solve this question? This one is quite very simple. Now, let's say how you can solve this question. If I give this expression here to differentiate this word given expression. In order to differentiate this one, to be the solution to this given question is to be equal to, we have the y, okay, I have the y ds to be equal to the y ds is equal to. So here we're differentiating. Let's differentiate this part. That is called what this s, this 2 are multiplied by this base, that is 2, okay, and subtract 1 for this one, that is s, that is 2 minus 1. I get down. That is what we just expression here. Plus the second term here, the coefficient, the index here is 1. That is 1 multiplied by, okay, multiplied by. If you subtract 1 from this way, that is s 1, because our s is one of 1, which does not visible. I get down. So we subtract 1 for it, that is minus 1. Now this one now becomes 2 minus 1, that is what? 1. So you have 2 or 2s. So because this s 2 minus is 1, so that means the s is power of 1 here, the 1 will not be visible. Again, because s is power of 1 is still that what? S. Plus, in this place we have 1, okay, multiplied by, y multiplied by. So if you look at this case now, we have s 1 minus s, 1 minus 1, that is 0. So it means that our s here is power of 0 here. So s is power of 0 is equal to what? 1. Anything is power of 0 is equal to 1. So therefore, this one becomes 2s plus, okay, 2s plus, that is 1 multiplied by, s is power of 0 is 1 multiplied by 1. So 1 times 1, that gives us 1. So therefore, our dy, okay, over ds, dy over ds is equal to, that is 2 or 2s plus 1 times 1, that give us 1. So the answer is to be equal to this. So that is if by differentiating this given expression, y is equal to 2s squared plus s, the solution is equal to this. These are the step by step to solve this question. I hope you guys it's well understood. If you don't understand, let me know in the comment section. So guys, let's move to the next class where we'll be discussing about the forms of types of differentiation and how to solve different type and form of differentiation. We are going to look at it in the next lesson. Thank you. God bless you. Don't forget to share with your friend.